Hello, my name is Grace Meshafedjan, and in today's presentation, we're going to be looking at different types of marble dividers in order to find what's the best fit for the Wintergatan Marble Machine X of Martin Molin. So first of all, what is exactly the marble machine? So the marble machine made its appearance to the world back in 2016 on the Wintergatan YouTube channel. And what it is just a machine that makes music using marbles to play different types of instruments such as the bass guitar, the cymbal, and the vibraphone. And the machine is activated by a crank, as you can see by the picture on the left, which raises steel marbles to the machine, and these marbles then pass through a marble divider and then drop from a certain height on different keys of a vibraphone, which is what makes the music. And then only 10 months after the first marble machine appearance, Martin Molin started working on Marble Machine X, which is the picture on the right side, and it's basically just the improved version of the original marble machine. And the interesting thing about it is that Martin Molin has been collaborating with different engineers and designers from all over the world in order to get their input and advice on how to better the initial marble machine. So coming to the marble divider, its mechanism basically divides one row of marbles into 38 separate tracks, which is separated into two parts with 19 tracks in each part. And each of those 19 tracks plays a different instrument, which is what makes the music of the marble machine. So however, we have a problem with this mechanism, and the problem is that the functionality of the marble divider is dependent of the top height of the top marble. And so since the marbles roll over each other, if the height of the top marble is too high, then the marbles behind it are just going to get stuck at that position. And if the marble is too low, the one marble will just drop in it, and the rest of the marble will just be stuck behind it. And so if there's no flow of marbles, there's obviously not going to be any music playing. So the aim here is to find a solution to this height problem. So thankfully, Martin and his whole community of engineers and designers have came up with a couple of very interesting solutions. The first one being Martin's solution. So Martin's solution to this problem was to create height modules, which are just these little cubes here made out of wood, and each of these cubes has different curves carved inside of them. And so basically, once these height modules with these different curves were filled with marbles, the top marble would stick up in different heights. And he could slide these modules in and out of the marble divider and change the height of the top marble. But thanks to his community of engineers and designers, he gets even better suggestions to solve the issue of the height. So a second solution was offered by Rosero, and what's very interesting about Rosero's design is that it offers a completely new approach to the situation. So instead of him determining on how to fix the height issue, he just got rid of the height issue altogether by designing a brand new mechanism that makes the marble divider independent of the top marble height. So the idea here is that the marbles will just drop down to a downslope channel that have 38 gates, and they're all adjustable in height. And the picture we're seeing here is just a prototype that Rosero sent to Martin, which is why it only has 10 gates, but the full scale one will have 38 gates. And the interesting thing is that the holes are placed on the right side of the track rather than them being placed directly on the track. Therefore, the marbles do not have to roll over each other, unlike Martin's old solution with the height modules. So when the marbles drop, the first marble will just go into the first gate, the second to the second gate, and so on and so forth, while the subsequent marbles will just run down the channel unbothered by the marble holes, hence unbothered by the heights of the marbles. So another solution was offered by Andrew Scher, and his solution was basically the improved version of Martin's old height module design. But what's better in Andrew Scher's version is that in order to adjust the height of the top marble over here, all Martin would have to do is pull the slider here in and out, and he can even adjust the height of the top marble externally with the screw over here. Unlike Martin's old solution, where in order to change the top marble height, he'd have to put in and out different modules according to the curve inside his little height modules. And another solution was offered by James C. and Sebastian Kirch. And what they did is they designed a trapdoor slash hook design. And basically the trapdoor allows the top marble to stay in a fixed position, and it gets released when the low marble gets released. And this is also a very interesting design because it also gets rid of the height modules altogether. And then the last solution that we see was offered by a designer with the username Consonator, and his design is a zigzag design where the marbles continuously flow across a zigzag row. So while the marbles flow, the front marble goes into the first turn of the zigzag, the second marble goes into the second turn of the zigzag, and so on and so forth. Eventually, all of the right turns of the zigzag will be filled with marbles, which will allow a smooth passing for the rest of the marbles. At the very end, Martin focuses on two possible solutions, one of them being Andrew Scheur's improved height module design, and the second one being Rosero's design. So coming to Andrew Scheur's solution, although it's a very good option, the problem with his height modules is that one singular height module contains 13 different parts, and in total we need 38 height modules along with additional mandatory parts. So Martin would have to source, manufacture, and assemble 622 different parts. And coming to Rosero's design, if we use Rosero's design, Martin would save 622 parts. And so he chooses to take Rosero's prototype and build it in full scale for his marble divider. And after testing it in different angles, making sure that it will work inside the marble machine, at the end we see that this Rosero's design works perfectly with the marble machine. So in conclusion, the best solution for Martin would be to implement Rosero's design, as it gets rid of the height issue of the top marble altogether, and it also saved him a lot of manufacturing time, and it works perfectly with the marble machine. Thank you for listening.